Alright, hello. My name is Juan Romero, and this is a presentation about how LLMs work. Now, large language models, right, or LLMs, right, they're transforming the way we interact with technology. A lot of people use this technology. A lot of people use large language models like ChatGPT, right? Now, even though a lot of people use this technology, a lot of people don't know how they work. So that's what I'll be trying to do in this video. I'm going to try to explain exactly how they work. Right? In this video, I'm going to be breaking down the key concepts behind LLMs, specifically the GPTs, and I'll get to what GPT means in a second. So what is GPT? Right? So it stands for Generative Pre-trained Transformer. So the generative part means that it generates new text, create new text, right? The pre-trained part just means that there was a process of learning through a huge amount of data. The transformer part is a specific type of neural network, right? A neural network that essentially tries to guess the next word on a snippet of a text in this particular case. Now, text, images, and even video are broken into small chunks called tokens, right? Now, these tokens are mapped to a numerical vector in a high dimensional space, right? Now, this dimensional space changes with the complexity of the large language model, right? Now, when these tokens becomes vectors, this is also referred to as encoding, right? Now, if we were to plot these into a graph of x dimensions, right, words with similar meaning would land near each other. Now, like in the real world, right, understanding words individually just by themselves, right, isn't enough. The context matters. This is where the attention blocks come in. Right? Now, when these vectors pass through the attention block, these vectors talk to each other. And when they talk to each other, they update values, they update meanings, right? This process determines which words are relevant in the given sentence. Right? The essential meaning of the word is baked onto the final vector. Let's take the word duck, for example. Now, the word duck could mean an animal or an action, depending on the surrounding words, also known as the context, right? So, through these attention blocks, the model learns which words influence each other, right? And it refines their meanings accordingly. And now we have the multi-layer perceptron. This step processes the vectors further. These vectors pass through a multi-layer perceptron or feed-forward layer. In this step, the vectors do not talk to each other. Each vector is passed through the same operations. Think of this as like asking questions about each vector and updating based on the answers. It's like asking, does this word make sense here? And adjusting accordingly. Now, for example, let's take a model that has X amount of words in the English language, and each word is embedded to a vector. Now, I have this picture up top to kind of give you guys an idea of what that looks like. Let's say that every vector up top is a word. Each of these vectors are first random, but then they become learned with data. Now, let's say that the user input says, I go to the park to walk my blank. Right? Now, the desired output is a probability distribution of what word might come next. So now we had our tokenization and encoding. Now our input text is split into tokens. Each token is converted into a numerical vector using learned embeddings. Tokens pass through the attention layers where they communicate to understand context. Once again, the example we can use here is duck. Could mean a bird or the action depending on the context. And then we have our MLP, or our multi-layer perceptron. The vectors are further refined here through feed-forward layers, which adjust their meanings based on learned weights. Now, after multiple attention and MLP layers, the model produces a final vector representing the predicted next word. This vector is then multiplied by a weight matrix to generate raw scores. This is where we apply the softmax function. This function converts the scores into probabilities, where the higher values mean that the word is most likely to appear next. So to summarize, LLMs process languages by tokenizing text, refining vectors through neural networks, and using probability distributions to generate coherent responses. This is what allows AI to generate meaningful text, not just a bunch of jargon, and even engage in complex conversations. I hope this breakdown helped you understand how LLMs like ChatGPT work